Hi, Mr. Richards here, and today we're going to talk about graphing equations in slope-intercept form. Our objective is to write and graph linear equations in slope-intercept form and model real-world data with equations in slope-intercept form. So let's get started with our key concept. And the slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. The y-intercept on the graph is where it crosses the y-axis, and the b is the y-coordinate of that point, since the x-coordinate will always be 0. And then m is the slope of the line, sometimes positive, sometimes negative. And you can see in the table where 2 is the slope and 6 is the y-intercept. Write an equation in slope-intercept form of the line with the slope of 1/4 and a y-intercept of -1. Then graph the equation. Well, if we start with the slope-intercept form, that is y equals mx plus b. Well, our slope is 1/4, so it's going to be y equals 1/4 x. We could write a plus -1 here, or we could simply write -1 for that y-intercept being -1. Now, with the y-intercept being -1, we can come down and graph a point at -1. Now, the slope of 1/4 means we're going to rise 1 every time we run 4. So when we start at our y-intercept, we would rise 1 and run 1, 2, 3, 4. From that point, we would rise 1 and run 1, 2, 3, 4. Now, if we want to go the other way and see what's going on in this side, we have to do the opposite of going up 1 and right 4. We'd have to go down 1 and left 4. In other words, starting at the y-intercept again, down 1 and left 1, 2, 3, 4. And again, down 1, left 1, 2, 3, 4. That's more than enough points to graph the equation here. Make sure wherever your last points are that your line goes through it. And since it is a line, we do need arrows on it. And so that is the graph of our equation, y equals 1/4 x minus 1. Now, the slope-intercept form again is y equals mx plus b, where m is the slope and b is the y-intercept. And in this question, we have a slope of 4 and a y-intercept of 3. So when we want to write the equation, y is going to equal our slope of 4x plus 3. Well, let's graph the y-intercept at 3, right there. And now a slope of 4. We can write as the ratio 4/1, with 4 rise over 1 run. And from the y-intercept, we'll count 1, 2, 3, 4, and over 1. And just like we did on the last problem, that could also mean 4 down and 1 left. So we can go from the intercept, 1, 2, 3, 4 down, and 1 left. Go ahead and draw your line through with the arrows on either side. It's supposed to be a straight line, but that is the graph of the equation y equals 4x plus 3. With this section being on graphing equations in slope-intercept form, here we're given an equation that is not in slope-intercept form. 5x plus 4y equals 8. Remember, slope-intercept form is y equals mx plus b, so we need to get this equation into slope-intercept form. I'm going to go ahead and rewrite this just to make it easier to compute with 5x plus 4y equals 8. Now, we need to get this y alone and everything else over to the other side so we can get the y equals mx plus b. Let's start with the 5x. Let's subtract 5x from both sides. And we're left with now 4y equals a negative 5x plus 8. Now is where it gets interesting, because we have 4y equals negative 5x plus 8, which is similar to our slope-intercept form, except here we have our y alone. So we need to get our y alone. Well, we need to divide then by 4. And when we divide this by 4, everything over here on the right side gets divided by 4. So that cancels, and we're left with y equals a negative 5/4 x plus 8 divided by 4 is 2. So this equation now in slope-intercept form is y equals negative 5/4 x plus 2. Now you can use that information to graph. Our y-intercept is 2. And then negative 5/4 means that I will rise a negative 4, so go down negative 5, as we run 4. So our rise is negative 5, so we go down 1, 2, 3, 4, 5. And then we run to the right 4. 1, 2, 3, 4. Now we can also go the opposite way. We can do a rise of 5 with a run of negative 4, which would be from the intercept 1, 2, 3, 4, 5, with a run of negative 4, so backwards 1, 2, 3, and 4. We have our 3 points, so we can now connect these as straight through the points as you can, going through both endpoints and drawing our arrows. So when we want to graph using slope-intercept form, using the equation 5x plus 4y equals 8, get the equation into slope-intercept form, and then graph using the y-intercept and the slope. One more example of this. Again, our goal is to get this into y equals mx plus b form. So I'll rewrite this once again. 3x plus 2y equals 6. And we want to get this y alone. So we need to first subtract the 3x from both sides. That cancels, and we're left with 2y equals negative 3x. That's a 6, so plus 6. Now we need to isolate our y, so divide by the 2 on both sides, but everything on that right side by 2. And so y equals negative 3 halves x plus 3. And now my equation's in slope-intercept form. My y-intercept here is 3. And my slope of negative 3 over 2 means when I look at my rise over run, that from the y-intercept I will go down 1, 2, 3, and then run 2, 1, 2. Again, I could also go the opposite way, going up 3 and left 2. So once again, from my y-intercept, up 1, 2, 3, and then to the back 1, 2. And now that I have my 3 points, go ahead and draw a line between them with arrows on the end. So again, if your equation's not in slope-intercept form, you can work to get it into slope-intercept form, graph the y-intercept, a point or two, and connect the dots. Now some equations are called constant functions. Now, constant functions are horizontal lines. So we have y equals -7. Well, remember, here's our y-axis, and where y equals -7, we can just count down. I mean, 1, 2, 3, 4, 5, 6, 7. Anywhere along this point, this line, y equals -7, regardless of what the x is. So we can just draw a line right where I'm tracing that laser. And that is the graph of y equals -7. Constant functions do not cross the x-axis is another thing. You can see it's just a horizontal line. There is no slope. Now, can we write an equation in slope-intercept form for the line shown in the graph? Well, if we have y equals mx plus b, that means we're looking for two things. One, the slope, the other, the y-intercept. Well, in this particular graph, the y-intercept is pretty easy to find. It's where it crosses the y-axis, and it gives us the point -3. So far we have y equals something x. We'll look for the slope in a moment. -3, or you could do y equals whatever x plus a -3, but I think that's more difficult to deal with, so you can just keep it -3. Now, as for our slope, what you're going to need to do is look along this line for a point where it crosses very nicely and very cleanly so you can identify a point. And you have a couple options, really. As you go up from 0, -3, it doesn't cross anything nicely where y is -2, but it does cross here at 1, 1. The next time it crosses is all the way up here at maybe 3, 3. But you definitely have one here at 1, -1. So you can kind of look at a point there at 1, -1. And you can determine the slope from here in several different ways. You could go your slope equals y2 minus y1 over x2 minus x1 to calculate. And then you would have, if you called the one down here x1, y1, and the one up here x2, y2, you would have -1 minus a -3 over 1 minus 0, and that slope equals 1 minus -3 is 2 over 1 with a slope of 2. So that's one way to get y equals 2x minus 3, or 2x plus -3. The other way is to go, well, slope is rise over run, so I'm going up 2 over 1, so 2 over 1. That might be your preferred method, but you can always use your slope formula to get that as well. Let's look at one more like this. In this graph, we have a negative slope, and it really doesn't give us any points. Remember, slope-intercept form is y equals mx plus b. And if we identify our y-intercept first, that looks to be the point 0, 1. And now let's look for a point on this line that crosses nicely that we can identify. As we go down, I think we have one right there. We also have one up here. And you could pick either to help you solve this. I'll pick the one down below, and this is at 1, -2. When we go to calculate the slope of that line, using the slope formula y2 minus y1 over x2 minus x1, remember, it doesn't matter what you call x1, y1, or x2, y2, as long as you're consistent in your formula. So this slope is going to equal -2 minus 1 over 1 minus 0, which is negative 3 over 1, or just negative 3. Again, if you wanted to count, you could also go, okay, my rise is from the starting point, 1, 2, 3 over 1. Another way to get to negative 3 over 1. Either way should work. So now we have y equals, my slope is negative 3x plus my y-intercept. My y-intercept is where it crosses the y-axis, which is at 1. One more to go. The ideal maximum heart rate for a 25-year-old exercising to burn fat is 117 beats per minute. For every 5 years older than 25, that ideal rate drops 3 beats per minute. So let's write a linear equation. And we have a table here to help us out, getting us from words to the equation. So the ideal rate is going to be R equals, now our rate of change. We're going down 3 beats per minute, but for every 5 years. So down 3 beats for every 5 years times the years older than 25, we're just going to label as A, plus 117. And that's our equation. Now when we go to graph this, we can count up on our graph 112, 113, 114, 115, 116, 117 is our y-intercept here. And on this side is our maximum heart rate. That's a bad heart. On the bottom, yikes. On the bottom is going to be our years older than 25, and for the sake of our graph, we can go 1 year older, 2 year older, 3, 4, 5 years older, 6 years older, 7 years older. And this is going to be the A, and this is going to be our R. Now, the first point in our graph is going to be right about here. Now, if you think about this point, 114 beats per minute, 5 years later. Well, we drop 3 beats per minute every 5 years. So that's our logical point there. And now we can just kind of draw a graph in. And that's how I would do that. Now, to find the ideal maximum heart rate for a 55-year-old person exercising to burn fat, well, let's start with our equation. R equals negative 3/5 A plus 117. If you think about 55, that is 30 years older. So we can put that into R equals negative 3/5 times 30 plus 117. And you can do some cross-simplifying here to make life a little bit easier. But R is going to equal negative 18 plus 117. And, of course, negative 18 plus 117 is 99 beats per minute. That's it. Good luck.